Good morning, everyone. My name is Shilpa, and I welcome you all to the CPP India user group community. First of all, a happy Independence Day to everyone, and thank you for joining in for today's session with the CPP India community. This community is for all those people who are interested in learning C++ language or are looking to upgrade their skills or knowledge about the language. It provides you with the platform to learn, discuss, or showcase your work done primarily in C++ language. Since we have so many people joining in for the first time, I would like to say a couple of pointers before we begin with the session. You can connect with the community through our WhatsApp group and Discord channel. You might have already received an email with all the links when you had registered for this session. In case not, please reach out to me, Dheeraj, or Vishal, and we can help you out. These sessions are recorded and uploaded on our CPP India YouTube channel. We will inform you whenever a new session gets uploaded on one of our groups. Hence, I highly encourage you all to join those groups as you will get all the latest updates related to the community over there. Post this session, you will get a feedback form. Please spare a few minutes to fill out this form as your feedback will help us to improve these sessions. I'm now done with all my boring stuff. So let's begin with the interesting stuff for which we have all joined in. Today we have Dheeraj here who will give some insight into the Move Semantics. Dheeraj has more than 9 years of software development experience and currently he is living in Bangalore City and working with Herman International Organization. Without any further ado, let me hand over to Dheeraj.
Okay, so we'll see this move semantic. This is introduced in 2011 with C++11. Okay, and we'll go from basics to advanced. Means how you can write. Means by the end of this session, I'm expecting that you will have a fair understanding of writing move semantics, move constructors, and move assignment operators and all that. Okay, and you will have a fair understanding of how move semantics works. So before we go into move semantics, let's take a few steps back and let's start with L value and R value, because it's sometimes it's a bit confusing what is actually an L value is and what actually an R value is. So when we write L equals to R, okay, so in this, before C++11, we used to say whatever appears on the left side of assignment operator, that is L value, and whatever comes on the right side, that is R value. Because before C++, there was nothing like R value. Okay. So if we consider this is true, that whatever is in left side is L value and whatever is in right side is R value. So let's see this example. Here we have a string, okay, and we have this statement s plus s equals to s. Okay, this is a valid statement. If you run this statement, you will not get any error, any compilation error. Obviously, this is not doing any thing, very valuable thing, but this will work. So if we go with this definition, so this will be a L value and this is R value, but this is wrong. S is an L value. Oh. So this S plus S, this is an R value, and this S on the right hand side is an L value. Okay. So how we can say what is L value and what is R value? So L value will have a name, and we can get an address of L value every time. Okay, so L value can be on the right side of assignment operator or on the left side of assignment operator. Okay, and R value will not have any name. Like in this example, if we see this S plus S, this is going to create another temporary object to which we don't have any name, and we cannot get the address of that temporary object. Okay, so this object of the result of this S plus S, whatever this object is, this is an R value. Okay, so let's see something in code that will give more clarity how the L value and R values are. Okay, okay, let me stop this slide and open my editor. Okay, so when we write int I, so in this statement, this is a L value because we can get the address of I. Okay, we can write like this. This is a valid statement. We can get an address of I. So I will be a L value. We can assign some value to this. Okay, and we can print this. That's pretty good. But in the same statement, in this I equals to 2, 2 is an R value because we cannot get the address of 2. We cannot write it like at this. We cannot do this. This will give us an error. Okay, so this is an R value. Okay, now if I write uh, x equals to I plus 2 again, this will give me a R value. Okay, and x is an L value. If I try to write a statement like this, this will be an error because we do not have access to this memory. We don't know where this is. Okay, so this is an example of R value. Now let's write one simple function, simple add function, and this will take two arguments and we'll just return a plus b. Pretty simple. Okay. Now let's call this function add with two values, 2 plus 3, 2 and 3. Okay. So what will happen now? This add function, when this statement will execute, execution will reach to this add function. It will reach to this because in this function we have only one statement. It will reach here. It will add a plus b, and it will give a temporary object. Right? The temporary object, whatever this is, this will get stored in this sum. Okay. So whatever is created temporary is created here, that is R value. and that we are storing in this L value sum. I think this is clear. So if we are returning from a function some object, some local object, it will come as an R value, and it will be stored in some L value. Okay, and let me show you the example which I showed you in, and just to show you that this is a valid example. Okay. This will run, this will execute. Okay, so we will not get any error, compilation error because of this. So this was just to show you that whatever code I showed you, this is pretty valid code, but this will not do anything valuable. And usually we are not going to use this anywhere, this kind of statement anyway. Okay, so this is something about L value and R value. In the sequence, we'll see something references. I'll remove this code. How the reference works. So if I have an integer I equals to 2, and I create an reference of I, okay, so this this will be called L value reference. Okay, if we try to create a reference of of R value like this, this will give an error. It is saying initial value of reference to non-const must be an L value. Okay, so it is expecting some L value here. But if I write const here, I think this will be pretty fine. Okay, so because using this const, we are saying that this is a constant reference to some R value. And I will give you one example also, which we used to use, and maybe most of you know this. When we create any when we write any copy constructor in our class, we used to write this kind of a statement, right? We whatever we are passing as a reference, we use it as a constant. Use this constant. So one reason is that it will not get updated inside the inside your copy constructor function. Another reason is if you don't write this const there in that parameter, in that argument list, it will not take any temporary object as a parameter. Okay, so maybe I will try to show you that. Actually, that is out of the scope of this discussion, but if possible, I will show you that in code how it happens. Okay, so if I write one function square, this will simply do some square. Okay, and I call this square function and store it into an variable. Okay, So we are calling this square function, and we are passing some I into this, and we are getting some value. It's printed. But if I write, I call this a square function like this will give an error. Cannot bind non-constant L value referenced to this. Okay, this is R value. Okay, and in this function we are taking the reference for L value reference. Means we are taking L value reference. So this will not work. So what if I write a same function with const here? Now this will work. Okay, here it is. You will see this will work because we have const here. Now it is a reference, it is a constant reference to some uh, value. Okay, so this is something about reference, and we just discussed that this is an L value. Okay, so why this L value reference, only this L value reference? Is there something R value reference there? Let's see that. Let me remove all this. If we have a variable 4, okay, and if we create a reference to this, this lvref is L value reference. Okay, we can do addition, and we can perform any operations, arithmetic operations, or anything. Okay, we can do all these things. Okay. And if we try to assign some different variable to this reference now, so now I'm going to 10, and we try to do this, we'll get error. Because we can only initialize a reference once, and when we are declaring at the same time, we'll have to initialize it with some variable. Okay, with some L value variable. But what about this R value? What is this R value reference? So there is a syntax for R value reference. For that we use double ampersand rvalue, and now we can write this statement. So this is an R value reference to integer. Okay, and this will work pretty good. Okay, and the another thing is we can reassign values to R value reference. Okay, so just for an example, let's write one function which will take an integer as an argument, and it will return return value multiplied by 2. Okay, so if we call this function like this will work pretty good. Okay, but the same function like this, same function if I call like this, this will give error. The same reason, because this is a R value. So now we can write another function, and we can pass R value reference. Okay, and now if we try this, so if I print it, run this, you will get, see, this R value reference, this function is get called. Now you can see there are two variations. Means we have overloaded this multiply by 2. One function is taking L value reference, another is taking R value reference. So is it required to write two functions like this? Can't we have only one function which will solve these two things, which will eliminate anyone? So let's try to comment this out. So this is working right now. Let's comment this. Let's see if this works. Cannot bind R value reference to this. Okay, we cannot bind because this is an L value. So we can't use only a function which is taking R value reference. So we'll have to have this. Okay, there is another way to solve this problem, and using that we can eliminate this function. It's only this one function will work in both the cases, and we'll see that in subsequent slides. So if I try to summarize everything in a single line, okay, so how I can say, if the expression has an identifiable memory address, it will be a L value, otherwise it's a R value. Okay, if we can get the address of some expression, result of any expression, that will be a L value. So that's why in this case we cannot get the address of this expression, so it is an R value, and we can get the address of this, so this is an L value. Okay, let's move forward. Let's create one vector with 4 values inside this, and this is how it will be, something in memory. Okay, so your vector v1 is having 1 2 3 4 values into this. Okay, and now let's create another vector, and we do not have anything, means we did not initialize it right now, and we have this v2, and now we write v2 equals to v1. What will happen in this case? When we write v2 equals to v1, in this case, one memory will be allocated for v2, and all the values will be copied to this this memory, and we'll have this kind of stuff. And so now there will be one copy v2, which is a copy of v1. Both the vectors will have same values, okay, but in different location, but they will have a same values. Okay, so this is how we used to use this expression very much. But let's see, if we have a function create vector and it is returning one vector, okay, and we created v2. This is empty right now. This is v2. Now we call this function create vector and we assign it to v2. So what will happen is this create vector will return a vector with values 1, 2, 3, 4, and it will assign to this v2. So how this will happen actually? This function call create vector function call will create one temporary object, and it will uh, have some memory. We will not be able to access this temporarily, so this is a r value. And when this assignment will happen, all these this memory will be allocated to v2 and temp will be deleted. This is what happens. Okay, before C++11 this used to happen. So now this temporary will be deleted. So there are a couple of operations, this temporary creation of temporary, and then this v2 will create, and this will happen, this memory passing will happen. In C++11 we have a standard function move. So the same scenario which we saw earlier, v1 equals to v2. Okay, let's see what will happen if we write if we use same write same statement expression with move. So we have v1 which is having pointing to this memory, and we have v2, and we called std move v1. In this case, in earlier case when we wrote v2 equals to v1, there were two copies. Okay, in this case when we call std move v1, it will this v2 will start pointing to this memory, and v1 will not have access to this memory. This memory will be moved from v1 to v2, and now v1 will not point to any memory. Okay, so when we have something which we want to move, that we don't want v1 now and we want to move everything to v2, in that case we can use this std move. Okay, so this is how std move works, means it will move all the memory to another one. But how exactly this move works? So this is the semantic for move statement. What it does inside is it will move this whatever we are passing, means it will create an r reference and it will move to the next means that it will just convert this reference, it will take as an r value reference, and it will assign to something means what to whatever we are going to assign. It will do a static cast. Because of that we will not get any kind of compilation error. Okay, so this is how this standard move function is from inside. So let's see the example which we saw earlier. In this example, If I comment this and if I write string move, okay, and if I compile, this will work pretty well. Now we do not have this function. We have only one function which will take a value as an R value reference, and we can pass L value and R value both, and we can run this. See, 2 times this will record this function. So what this will do is this will convert this L value to an R value reference, and it will pass to this function. Okay, so if we use std move, in that case we will not have to write this function which take L value reference. So this if you have something like this, these two functions like this, and or you have something constant or something written here, so by using only this std move you can remove one function from your code. Okay, let's move to the next thing, move constructor and move assignment operator. What it is and how we can write it and what is the syntax, so we will see. So this is the semantic for move constructor. Yeah, for move constructor, and this is for move assignment operator. If you see closely, we are using double ampersand here. In a normal constructor, we use in normal copy constructor we use single ampersand here. Okay, but in case of move, we use double ampersand because we are passing object as a R value reference. Same in assignment operator. So by default, in C++11 onwards, you get move constructor and move assignment operator. Means if you if you have a old code and you just compile it with and you are using lots of standard containers and everything, so you just compile it with any compiler, C++11 or onwards, any compiler, you will get some performance benefit, because this move semantic is implemented for all the containers we use, vector, map, and everything we use. It is there for in standard library. So if you don't make any change, still you will get some better performance. So by default, what all things comes in with a class when we write, it is constructor, destructor, copy constructor, assignment operator. This we used to get. Okay. Now from C++11 onwards, you will get move constructor and move assignment operator by default. Okay. So these are the 6 special functions you get. And there is one C++ core guideline. If you can avoid defining default operations, do that. Means it's better to use default operation than writing your own. So if it is possible, please use default operations. And this is also known as rule of 0. I will give you a reference link in the last slide of all these C++ core guidelines. Whatever we are going to means, I'm going to tell you in this session, so you can refer those uh, after that. Okay. So what move constructor do? Actually, a move constructor uh, do a transfer of content. Okay, it will transfer the content of one object to another object, and it will leave the first object in a valid but undefined state. Okay, so there is another C++ core guideline which says a move operation should move and leave its source in a valid state. Okay, ideally that move from should be the default value of the type. Ensure that unless there is an exceptionally good reason not to do this. So what this means is, if you transfer one object to another, you move all the memory allocated, all the resource allocated to first object to another, and if possible, leave that object in with the default values, and don't use it because it will be in a invalid state. Means undefined state, not invalid, undefined state. So let it die. Don't be emotional with that object. Okay. So let's see how we can write a move constructor. Okay. So let me remove this stuff. Okay. Let's create one test class. Okay. And this will add one constructor. Before adding any constructor, let's add some data to this. I don't know what this will do, so I will name it as no idea. And let's add one integer pointer. Okay. And let's add one constructor to this class. This is a default constructor for this class. Let's add one parameterized also. Okay. And we'll add one copy constructor also into this, because these are the all four things we use to get copy constructor and as default assignment operator for C++11. Okay. Now let's add one function which will give us object, which will return an object. Means whatever object we are passing, it will just return that object. That's all. We are not doing anything creating this. Okay. Let's have this, and let's add one print function to see what will be the state of the variables members we have in this class. So if you want to check, we can check it from here. So this print function will print the value of this no idea and the address of this PTR, this pointer, whatever address it is pointing to. Now let's create one test object. And let's pass it from object like this. Let's see what happens. Will it compile? Yes, it is. And called test object. Okay. The constructed this object. This is a parameterized constructor, so it is calling parameterized one. Then this function, it went inside this function, it printed this create test, and then it called a copy constructor here. Okay. Now let's add some syntax for move constructor, how we can write it. I'll add one separator here. And we'll just print one statement inside this, and we'll see what happens. We'll print move. As soon as we wrote one move constructor here, this is calling move constructor. Okay. Right now we are not doing anything inside this constructor. We will do that, but just I want to show you that this will call a move constructor because we are passing some temporary object here, and it will move this object to this object one. Okay, and we can print this values inside this print function. We can see what actually it is printing. See, it will print some. It is printing some garbage right now because we are not doing anything inside this function, this move constructor. Okay, so let's write this move constructor. We'll go step by step. So what is the first line it was saying in this move constructor is it is saying transfer the content. Okay, let's okay, let me write this these two statements here so that we will see exactly what we are doing. Okay, so first we have to transfer the content from one object to another. The object we are passing to the object to which we are passing. Okay, so let's move. We have two members in this, so let's move this first variable. So when we write this, means we have to transfer the content, so we will transfer the no idea from object we are passing to the object to we are passing. Okay, means we are created a temporary object from this to object one. So there is means if we don't write std move because no idea is an integer, it will work. There will be no problem into this, but it's better to use a standard move because if in future you change the type of this no idea, okay, you will not have to make any change here. You can directly change the some, maybe you want to create it, make it as another class or something. You will have to just make it as a class, and this line will work properly. Okay, so we will move this to no idea. This no idea means no idea of object we pass to object we want to move. Okay. And next we have pointer here. Okay. So we'll move this pointer with this standard move function. We'll move this pointer to this our object's pointer. Now we did this transfer thing. We transferred this content. So this first step is done. Now next it is saying it should be in a valid undefined state. So now we'll have to make it a null PTR. When we do this, now this object is a valid object, but its state is not defined. It is not pointing to any memory or anything. Okay, and for safer side, we can do this also. Maybe if in case of integer, it's not required something. But if you have any user-defined class, you can add something with some default values or something to this here. Okay. Okay. So these two lines, there is a function added in a standard library which we can use is standard exchange. Okay. What this function do is it will move the content of this. Yes, this line will be like this. It will move the content of this to PTR, no idea, this one, and assign it to null PTR. So instead of writing two lines, we can use this single line also. Okay, this is a part of a standard library. I will share the link in the reference section, which you can refer. So we did two steps now, and this is our copy constructor. Move constructor. Let's run it once. We have 30, and we have some memory we are pointing to. Okay, so this is the basic how this move constructor will be. Based on your requirement, you can write your own move constructor using these two steps in mind, keeping these two steps in mind. So we saw that write a move constructor, we have two steps. One, member wise move, and then reset the moved object. Okay, and with this there is one code C++ core guideline which says make move operations no except. Means you should not throw any exception from operators, move constructor or move assignment operators. Okay, you should not throw any exception. Means in daily day-to-day life, this may not seems very useful, and this is a guideline, this is not a standard. So C++ will not force you to write no except, make your move operations no except. C++ will not force you, but it's a guideline. In some cases when we use vector, in those cases this may give you a performance benefit. Okay, so it's a guideline that use no except. Okay, don't throw any exception from your move operations. Okay. Now let's move to move assignment operator. So in this we have three things we have to do. First thing, clean up all the resources. Okay, means okay, I will explain this in code that will give more clarity. Second is transfer the content. Third is leave move from object in a valid and undefined state. So these two, second and third line, this second and third point, this is same as in move constructor. This first point is new to this. Okay, so let's see into the code. Okay, let's use this one only, and let's write one assignment operator. Sorry, move assignment operator, and we'll only add one print statement right now. Okay, let's comment this. See what happened in this line. Comment these print statements. Okay, here we already saw these three lines are printed. Here copy constructor is printed. Now in this line we have this default object is created at line number 74, this object 3. Then we used standard move to move object 2 to object 3. Okay, so this move assignment operator is called, which we just created, and we are not doing anything inside this function. That's why we have some garbage value here. Okay, we do not have anything. Okay, so let's see what will happen. Okay, right now we are not doing anything, so we'll check this later on. Let's add some relevant code inside this function. Bring these things here. We'll see each step. First, clean up all the resources. Whatever we have assigned to this object to which we are this object means this object 3. First, we'll have to clear all the resources we are having. So to do that, we'll have to delete I'm using this here just to make it clear that we are deleting PTR no idea of ourselves, not of object. Okay, means it's not required. You can directly do this, but just for clarity, I'm writing this. Okay, so now what we did is we clear the resources whatever we are having in our own object 3. In this object 3, we are deleting that resource, and now we'll move all the members. Okay, so we'll move all the members here. Okay, and leave the object in a valid undefined state. Let's this. Okay. So we had three steps: clean all your resources. So we deleted whatever this object is owning. We transferred all the members, and now we are leaving this object in a valid undefined state. So this will be our move assignment operator. Now let's see. Add some codes here. So yes, in the terminal it will be clear that where we are. Okay. We created this object 3. Now we got move assignment operator, and all the objects are all the parameters members are moved to this object 3. Let's print this here and see what we have in object 2 and what we will have of in object 2 post. Okay, so we have in object 2 we had 60 and it was pointing to some memory. Okay, we did movement. Okay, we moved object 2 to object 3. Now object 3 is having the no idea equals to 60 and it is having the memory. It is pointing to the memory which was actually pointed by the object 2. And now in object 2 we resetted object 2 and it is not pointing to anything. So this object 2 is valid but undefined. It do not have anything, any data, relevant data. Okay, we can use this object 2 afterward, but we will have to take the responsibility. Otherwise, as from the guidelines, it says leave this object to die. Don't make any emotional relation with this object. Once you move, because when you are moving something, it means you don't want that older one. Okay, when you are moving object 2 to object 3, it means you don't want this object 2 actually. That's why you are moving. If you want object 2, then better make a copy, right? So this is how this uh, move assignment operator is. Okay, we'll see. Uh, and the example I wanted to show you related to move constructor. Actually, I wrote it wrongly. I wanted to do something like this. So this will move. This will call move constructor, and it will move. So I just wanted to show this standard move function with the constructor. How it is calling constructor. Okay. So
Excuse me, can you go a little up to the
yes. Wait. Here.
no to the move operator? Yeah, so
Here. Okay. This one, right?
yeah, move operator definition.
Move assignment operator definition.
Yeah,
This one. Okay. Yeah.
right. So we are doing this delete on PTR no idea, so that memory will be freed, and then when we move this empty memory to a destination object, uh, mm, I'm not sure the destination object will have access to that memory.
See, when
Even though
we
the
are
pointer address is moved and it is printing the right pointer address,
Mhm.
but if you want to create something in that memory, you will get an error because that memory has been freed.
No, I think you
Maybe I'm
misunderstood
missing
something.
something. Yeah.
Yeah, yeah. I will. This delete what we are doing. Okay. Let's say we have one object two. Okay, and we are moving it to object three. Okay.
Right.
So for this, we write this statement. Correct.
Right.
So now what we are doing is from object 3, this move operator will be called, right? This is what happens in case of assignment operator,
Okay. So I thought
right?
like it will be caught from the object 2. So
No.
that,
So it will be called from object 3, and this delete will happen on object 3.
got it.
So if object 3 is having any resource pointing to any resource, that will be freed. Okay, and then from object uh, from object 2, all the resources will be copied to object 3 in these two lines, and then all the resources will be freed from, means all the members of object 2 will be set to default pointers to null and like that. Is it clear?
Yes. Now it is clear.
Okay.
I thought it was reversed.
No, because operator assignment operator and normal assignment operator is also called on the
Right.
left
Right.
hand side.
Yeah.
Yeah.
Yeah. Correct. Yeah.
Okay.
Got
Okay.
it. Thanks.
Hi. I need to add on the mm, Anurag comment over here. So rather than deleting a pointer over here, why couldn't we leverage STD exchange mechanism here in move assignment operator?
STD exchange here you are saying, right?
What you means if earlier you says STD exchange is like you pass a destination and the source. So whatever this pointer is currently be pointing will be pointed by the assignable pointer reference, and this will be pointing to the pointer where we want to move this pointer to.
Okay.
Or
Okay.
XTD exchange doesn't fit into the current situation.
Yes, means you mean to say instead of writing this, we write STD exchange and means
Yeah,
something like this you want to do.
yeah, we could have done that.
Yeah, this you are saying, right? Means it will be moved
Yes.
to some. Okay, I will tell you why. What's the problem here? If we do this, okay, if we do this, what will happen is the address, the memory address, which is in object, this object, right? That will
Mhm.
be copied to this. That address will be copied to this. Okay, and this will become a null PTR. So that is pretty good. But we need this. What about the resource this PTR no idea is pointing to? We did not freed it. It will become a memory
Okay.
leak, right? So we
And
can, yeah, we can write this line. We can write this line and eliminate these two lines. That will be pretty good. But this is required.
And do we need a null check before delete?
so yeah,
I don't think null check is required. If you delete a null pointer, it will not give you any problem. So we saw in move assignment operator, we have three steps: cleanup, member wise move, and reset. Okay. There is few core guidelines which I will take you through. So now in any class, we have default these six operators, these six default operations we have. Okay, so which we already saw this, that destructor, move, assignment, constructor, all this. And another guideline is if you define or delete any move, copy, any destructor function, then do that for all. Okay, I will try, take you to again back to the code, and I will show you, and you will get to know the reason. Here we were doing something, and there move this standard assignment operator was printed, right? The reason was when we uh, just a minute. Reason was when we define any uh, constructor and any destructor, move constructor, anything, even define or even delete. When we do default, when we use delete, it means we are writing something about that function, about that. In that case, compiler will not generate move operations or other default operations. So you will have to write all your operations in that code, which at that time we had constructor, copy constructor, and assignment operator user defined. So compiler did not generated move assignment operator for us. Okay, so if you are doing, if you are writing, if you are defining any of these six functions, you will have to uh, define all. Okay, if you use this default or delete, it means you are defining, and you will have to define all. Okay, and this is also known as rule of 5. So this is what is in about this default implicit declared constructors. If no user defined move constructors are provided for a class type, there is no user defined means there is no user defined move constructor. Okay, and we do not have any copy constructor, we do not have any copy assignment operator, we do not have any move assignment operator, do not have any user declared destructor, and we did not implicitly defined constructor is not defined as deleted. Okay, implicitly declared move constructor is not defined as declared. And if we fulfill all these, then the compiler will declare a move constructor as a non-explicit inline member function in the class. If we have any one of these, compiler will not generate any move constructor. Okay, and as I said that make your move operations no except. Okay, sorry. So this is all from my side. If you have any question, please ask me. Move. We have I have added all the references here. Okay, you can check these links. That's all.
Okay, so thank you, Dheeraj, for the wonderful session. This was one of the most interactive sessions that we have ever had, and I hope everyone have enjoyed the session and learned something new. Just a quick reminder that you all will receive a feedback form in some time, so do fill it out and help us improve our sessions. And also, we are now active on social media as well. We have social media pages on LinkedIn, Facebook, Twitter, and YouTube channel. So I would just request you all to please follow us and spread the message. I have shared all the links on the group chat. Dheeraj, I will just post the web page link in a minute. Yeah.
Yeah, sure, sure. Or don't worry,
I
don't
think
worry. We are going to send a mail. So in that mail, we'll share all these details. And guys, because this comes as a bulk mail, maybe mails will go to your spam folder. So please check that and mark it as not spam, so that you will get in your main inbox all the mails.
so. I
Yes,
think
Shilpa.
we are done now for today.